Good day, class. Today we'll be doing the assignment method. So what you need to do is to ensure that you have the handout, you have downloaded the handout, the literature of the project management assignment method literature. Now, also you will have 2 exercises as well, and we are going to be going through those exercises while we go through the methodology of the assignment method. Now, the assignment method involves assigning tasks or jobs to resources. Examples include assigning jobs to machines, contracts to bidders, people to projects, and salespeople to territories. Now, the objective of the assignment method is often to minimize your total costs or the time required to perform the task at hand. So one important characteristic though is that you have limited resources, in that you may only be able to put 1 job to 1 worker or 1 machine to 1 job or a project. Now, each assignment problem uses a table, and the numbers in the table will be either the costs or the times associated with each particular assignment. Now, one thing that is unique is that you can only give 1 job to 1 person or 1 job to 1 machine, because you are limited with the resources that you have. Now, also, what is unique is that each job or each person that you're using, they would have a different cost for doing the different jobs. So you have to now be looking at the cost for each person or the times associated with each activity, and then using that you'd have to decide which job are you going to assigning to which person. Now, using the handout, we will be doing the first exercise, which is the Blue Mountain Print Tree. And this organization has 3 jobs, which you will see already written up on the board. 3 jobs, A, B, and C, and we have graphic designers, Eddie, Sharon, and Junior. And the figures in there represent the cost. So Eddie, to do job A, would charge $11. Sharon, the same job, it would cost us $14, and Junior, it would cost us $6. Likewise in B, Eddie would charge, or it would cost us $8, $10 for this, and $11 for that. For job C, Eddie would be $9, Sharon would be $12, and Junior would be $7. Now, looking at this, you may try and guess which one you would use right off, and you could probably do so, but we will be showing you the methodology that we use whenever we have assignments such as this. Now, this is easier because you have only 3 persons that you're going to assign 3 jobs, but the next exercise will have 4, and it becomes more difficult. The more the numbers increase, it becomes more difficult. So today we are doing an easy one, and this one here is, as we said, the Blue Mountain Company has 3 jobs, and these jobs are to be assigned to 3 computer graphic designers. The following table provides the data as to the cost of each job when designed by each graphic artist, as I said. So you should be looking on your exercise right now. Number 1, it's asking you to determine the assignment of jobs to machines that will minimize the printer's total cost. And then what will be your total cost when you finish assigning your jobs. So the first thing we are going to do now is to look back on your handout, and we are going to go through the steps that they have here. So the assignment method involves adding and subtracting appropriate numbers in the table in order to find the lowest opportunity cost for each assignment. What are opportunity costs? Opportunity costs are those profits foregone or not obtained. So we are going to be following the steps, and you're supposed to have your handout now looking at. It says here the first step, and we are going to go through it now, to subtract the smallest number in each row from every number in that row and rewrite the matrix. So we are going to subtract the smallest number in each row from every other number in that row. So the smallest number in this row, you have 11, 14, and 6. The smallest number is the 6. So we are going to use the 6 and subtract the 6 from every number in that row. So we're using the A is going across here. So the 6, we're putting the 0 here, 6 from 6, 0. Then we're going to subtract the 6 from the 14, and you get 8. The 6 from the 11, and you get 5. Good. Now the next row for B, job B. What is the lowest number here? The lowest number is the 8. So 8 from 8 is 0. So you put the 0 here. Then the 8 from 10, you get 2. The 8 from the 11, you get 3. Now the third row, job C, the lowest number is the 7. So you take away 7 from 7, you get 0 here. Then 7 from 12, 5. And 7 from 9, 2. Okay, so now that was your first step. The second step is from the resulting matrix, that's this, subtract the smallest number in each column. So we are now going to be looking at the columns. And we are going to subtract the smallest number from within each column from every number in that column. So this step has the effect of reducing the numbers in the table until a series of zeros, meaning zero opportunity costs, appear. So that was step number 2, which we are going to be carrying out now. So we are looking at the column, and the smallest number in the column there is 0. So once a 0 is in there, you're literally rewriting it, because 0 from 0, 0, 0 from 3 is 3, 0 from 0, 0. Okay, the second column, which is the 8, 2, and the 5. What is the smallest number? The smallest number is a 2. So 2 from 2, 0. 2 from 8, 6. 2 from 5, 3. So now you're looking at Eddie. And the 0 is the smallest. So you put the 0, the 5, and the 2. Alright, so step number 3. Step number 3 says draw the minimum number of vertical and horizontal straight lines to cover all the zeros in the table. So you're going to be looking at here now and try to see how many lines can you use to cover all the zeros. The minimum number of lines. I'm not talking any arbitrary number of lines, the minimum number of lines. You could say, okay, I can draw down 1, 2, and 3, but that's not the minimum number of lines. Do you see the minimum number of lines? It is not 3. What do you get for the minimum number of lines? Can you tell me? 2, that's right, 2. So let's go now. It would be here and here. Here and here. That would cover all the zeros. So it means then that if the number of lines is less than the number of rows or column, and we are doing a 3 by 3 matrix. So if the number of lines is less than the number of rows or columns, then we continue to the next step. So I hope you are following me on your handout. It says now that subtract the smallest number not covered by a line. So I'm going to just draw a line through here. That's that and this. Can you see that? That's this and this. So step 4 is subtract the smallest number not covered by a line from every other uncovered number. So what is the smallest number not covered by a line? Well, looking on this, you can see the 2. The 2 is not covered by a line. So you have to subtract all numbers not covered by a line by the smallest number, which we have identified as 2. So we are going to use 2 and subtract 2 from 2. You get 0, because that's an uncovered number. The 5 is an uncovered number, so we're going to subtract the 2 from that. We get 3. We're going to subtract the 2 from the 3 here. We get 1. We're going to subtract the 2 from the 6. You get 4. Okay. So then it says now, do not change the value of the numbers which are covered by only one line. So we are not going to change it. So we're going to put that. But before we did that, it said here that we are to add the number. Do not change the value of the numbers which are covered by only one line. But before that, it said add the same number to any numbers lying at the intersection of any two lines. So the 2, we are going to look now and see where is the intersection. That's here and here. So 3 is at the intersection of the 2 lines. And it says here in number 4 step that we are to add the same number lying at the intersection of any 2 lines. So that is the 3. And we're going to use the same 2 here and add it to the number that is at the intersection. So 3 plus the 2 gives you 5. Now you look back. Let's see. So we are to return to step 3 if we are not able to draw the number of lines that equal to the matrix. So let's look again. How many lines do we need to cover all the zeros? Okay, let's go again. We go 1, 2, 3. Yeah, 1, 2, 3. Let's use the same pattern. If we went like this, 1, 2, this would be left out. So obviously it is 3 lines that we are going to need. 1, 2, and 3. That way or this way. So we have reached the matrix here, which is going to allow us to do our optimal assignment. Now, number 5, step 5, optimal assignments will always be at 0 locations in the table. Now, the point we are at now, you have to think a little, because you are now going to choose which position, right? Which assignment. We are going to be looking now and choosing which one for A. So this is for A, B, and C. Now, A, you can only choose a position where there's a 0. So A can be Junior, B can be Sharon or Eddie, job C can be Junior or Eddie. So we have to assign the jobs to the designers. Now you normally start, it says here that optimal assignments will always be at 0 locations in the table. Now, one systematic way of making a valid assignment is first to select a row or column that contains only one 0 square, which is obvious because you don't have a choice. We don't have a choice, so A only has 1 here in this row. Yes, if you're looking down here, you see here, but let us use, you can either go by just selecting the rows, or you can look by working off the columns. So we're going to work off the rows. A only has 1 0 in here, so it must be at this position. Right, 1 0. Now, it means that I'm going to be using Junior for A. So, for job A, I'm going to use Junior. So Junior is finished. So this one that is down here for Junior, I'm going to just put an X here so I know I can't. This one is now out of the decision. Now, B, we have 2 zeros here, but we're not sure which one yet. So we're going to leave that one out right now. C, you come across, you cannot use this 0 again because you cannot use Junior again. We have already assigned a job to Junior. So C now only has one more 0 here. So for job C, we only have Eddie left for that. So if Eddie is going to be doing C, that means this one is gone for Eddie now. So now you can see job B now is left with 1 0. So by a matter of elimination, so job B will be given to Sharon. Okay, now that we have seen who is going to be getting what job, we are going to look now and see what is the cost, because the question asked you what is the total cost of your assignments. So now we are going to be working out the total cost of our assignments. For us to do that, we have to go back and look at the original table to see what figures are in these positions. What figures are in these positions over there. So if you look at Junior, you will see here that, which is the 6. Sharon is in the middle here, which is this 10. And the C now is at this position, which is a 9. So I'm going to just write it out here now. Alright, so let's go now. So Junior is 6. Sharon is 10. And Eddie is 9. So when you add that up, you get 25. So that is the answer for this exercise. So thank you very much, and please make sure you review it.